Well, welcome to Rob's Fix-It Shop. I'm always one to keep up with modern technology. So what I have on the bench today is a Lafayette model TE55 tube checker. And I saw it cheap on Facebook Marketplace, and I thought I'd pick it up and try it out and just, you know, see how it works. And so today on the video, I'm just kind of go through it, show how it works. We'll open it up, take a look at it, um, and just kind of discuss how it works. So if you're interested in that, hang on. It should be a fun ride. All right, so let me just talk quickly about how this thing works as I'm able to figure it out. So, or how you use it. So let's say we've got a 6BQ5, right? And it's new. Come on. Right, so what I'll do, so I'll go into the chart and find it. Yep. And so here we've got that right here. And so we set the filament volts to D. That's set at D. We set the filament to 4. All these switches go in the down position. And then we'll set the filament to 4. So we move 4 up to filament. And then N is 1, 6, and 8. And that just means no connection. 1, 6, and 8. So that means it's connected to nothing. And then the plate is 2. Right? So once we've done that, we double check to make sure our filament is in the right place, right? Because we don't want to wreck the tube by having the filament in the wrong place. Then we'll plug that baby in. And we move it to quality. Perfect, right? So it tells me the tube's good. All right, so let's try a different one. I'm just going to turn it off. And so here we've got high and low. So high is, I think, 115 to 125 volts, and low is 110 to 120 volts. And so we want to be in high. So let's say I've got this baby here, this Delco 6L6. Okay, so move everything down to the bottom. Right? And filament is D. Filament switch is 2. So that's pin 2. And so these numbers here refer to the actual pins. And then for plate, we want 5. And a load of 30. Good. And our filament is at 2 and 7. That becomes important when we check for continuity. So plug this in. Turn it on. And this tube was actually, my mom was at a garage sale and she found this box of tubes that she picked up for me. And so there's all kinds of stuff in here, and they look like they're all new old stock. So that's kind of cool. But I've just had them sitting around here. But then, yeah, so we can see that this tube is good, right? All right, let's just try one more. I mean, you're getting a general idea of how this is done, right? Um, so here we've got a Crosley twice tested service part. I think we can test this one. Let's slip it out of the box. And this is, what is this? I don't know what it is. Hold on, let me check. Oh, it's a 35C5. So it's a 35C5, so that's got 35 volts filament. So let's see if we can find that in here. Oh, that, okay. I'm going the wrong direction. So the chart goes up in filament value. So if we go to 35, oh, here it is, 35C5, and it's got this little asterisk near it, which means tube listing power switch must be switched down to the low position. No idea why. We'll do that though. And of course I lost it. 35C5. So set everything down. And then we've got filament volts is F, right? So that's the 35 volts. Filament is 3. No connection on 7. Because everything's to ground. Anything in the K position is always to ground. So we have to move it up to N to be a no. And plate is 1. And okay, so let me just double check. So let's plug this guy in. What? Okay, I don't get that. Hang on. Oh, interesting. So I wonder if our okay, hold on. Let's shut it off. Let's put a little deoxit on these pins. Deoxit. Well, then it tests good. Yeah, so I wonder if we just had a bad connection here before. Because yeah, it's a brand new tube. But it's probably had a rough life too. Get that back in its case, which is quite a complicated little box. Okay, so here, I don't know why, use slightly bad 6BQ5. Let's try that one. It's an Admiral. Huh. I don't know where I got this, but let's look that up. 6BQ5, so let's just turn it off. And we want to go to D. Everything down. Filament is 7. No, filament is 4. 1, 6, and 8 are no connection. And 2 is the plate. Okay, and we turn it on. Okay, well, let's see what we got here. Oh, very interesting. So this tester says it's good. I don't know. Who knows what I got it out of. So that one tests good. Let's check it for continuity. This one's clearly got a bunch of shorts in it. Put it in, short there, short there, short there. Yeah. So this one's shorted like crazy. So there we can see how to use it, right? So let's kind of think about how it actually works, right? Because it's not at all what I thought. So I just want to do a little, just kind of go through how I think this thing is working. So generally with a vacuum tube, you've got a plate and you've got a cathode, right? And the plate then goes through a current limiting resistor to some high voltage. And that high voltage is, can get pretty high, right? Like even 350 volts or whatever. And that's oftentimes referred to as B plus. And then the cathode's then going to be around ground. And so what happens is when you put a heater down here, so that's just a coil of wire that gets very hot. Put a heater down by the cathode, then the electrons naturally flow through this vacuum from the plate to the cathode, right? I mean, that's basic vacuum tube theory, right? And that then if you, so you get this current flow through here, and then if you take what they call the grid, it's just a screen, and you put it in here, then this flow of electrons can be interrupted by a voltage coming through here. So if we then put some kind of a signal like this through here, then that signal is going to be represented through here, but a much higher amount, right? Because this is a lot of current, a lot of voltage, right? And so we have a small signal here that ends up being a large signal here, which is why vacuum tubes are very good amplifiers, right? And but that's not how the tube checker works. It kind of does. Well, let's go through how the tube checker works. So on the tube checker, we have our same tube. We got our cathode and our plate and our grid, right? What we're doing here is we are taking all the tube elements except one, and we're tying them together, and we are tying them to ground, and then we're taking the grid oftentimes, and then we're putting B plus into the grid. And then, and there can be other elements in here too, like a second grid. And again, that'll be tied through this resistor to ground, right? And so our current flow is going to be, through here, through all those different elements. right? And so the tube is going to be acting like a diode, and with the current flowing through here, and then we have a current limiting resistor, and then we put the meter then is across that resistor. I don't know, how do you draw a meter, right? So that meter then is across that resistor. The resistor is actually adjustable to create more load or more resistance to that current flow um, for that tube, right? And so you match this to the amount of current flow that should go through here, and that's how you get that needle to come over here for a good tube, right? So I think that's how it works. All right, so let's just go through the schematic a little bit, and it's a little bit hard to follow because of the way the switches are kind of drawn out and the way the labels are done on the switches, but this is a non-polarized plug, but just for simplicity, I'm going to say that this is the neutral side and this is the hot side. And obviously it could be plugged in either way. But for the neutral side, we're just going to come up, through the switch, and we're going to come through, and this is the K switch. So that on the K switch, you have one of the pins connected to K. It's going to be connected to the neutral side. And here I just kind of drew out, a couple of the couple of the elements coming up, or the pins coming up through that neutral side. And then the other side of the neutral is going to be coming to our auto transformer. And yeah, so that's the neutral side. And then on the hot side, we're going to be coming up, we're going to be connected to the auto transformer. And for the purposes of the qualification and making the meter deflect, we're going to come off here at the 35 volt point right here, right? And we're going to be coming down through here, through a switchy switch, back up here, right? And then we're going to be coming through this load resistor right here. And that's kind of the, with that load resistor, then we can load up the circuit, and then we can also look at the test the voltage across that resistor, and that's what the meter's doing. So the meter's here, it's across that resistor, but what we're seeing then is we come through that resistor, we come back down, and we come back through our P switch and through here, right? And so that's kind of the heart of the current flow. The current flow comes through here, through the switch, kind of up through here, through this load resistor, back down, through here, up through here. And really what you're going to see then is you're going to see the current flowing from these things into here, through the tube, right? So this part here represents the tube itself. So one thing about this device that's bad is that it's got a non-polarized plug, and if you have the plug plugged in the wrong way, it electrocutes you or gives you a good shock. And so I'm going to see if I can open it up, take a look, and fix that. But it's clear that somebody's been in here before, because some of these screws are stripped out. Yeah, that's really stripped out. And this one's so bad, I can't do anything. Let's see if I can get something on it. I also want to Those switches are so tight in there. Wow. Well, that's pretty cool. That's pretty cool looking. So here's our auto transformer. Yeah, that looks pretty nice. High quality. So why is it giving a shock, right? Let me show you what I mean. So I'm plugging it in, and okay, we're on. Yeah, there. So if I go from here to here, 124 volts, right? So we've got our full voltage coming out on the case if the plug is turned around the wrong way. But where's that happening, right? I mean, all right, well, let me just do a little bit of inspection. Okay, so here I'm hooked up to here and the chassis, and I've got almost a dead short, and so I just need to find, I mean, obviously nothing's going to be soldered to here when you've got a non-polarized plug, but oh, what did I do there? So it almost looks like, let me see if I can zoom in on that. So right now we're reading 1.8 ohms, and I'm wondering if it almost looks like, can you see that? Something about, okay, so there I've got 1.6 ohms. What is it about? It could be that this nut is touching right here. Let me see if I can move that clip away. So we're 1.6 ohms. And then when I touch this, okay, so we still have it. So I think that power light is leaking. Yeah, that's the AC indicator. And that is going right over to power. And so it's almost like this, yeah, so this is a neon in here, but it's somehow leaking. So let me take that out. So here's our problem. We can focus on that. Yeah, it's just touching right there. And that's it. So I think if I clear the solder away. Okay, so I'll fix that, and then I'll put a polarized plug on here as well, so that does not happen again. All right, I'll be back in a minute. Okay, that looks good. So let's pull up this guy and see if we're good here. Yeah, that doesn't look great. It's reading 29 picofarads. And I think that's 1 microfarad, right? Okay, so I got the new resistor soldered in there. So then, got a new cord, and let's see what it takes to get that put in. I think I'm just going to take this other one out, and I don't think it matters which direction I put it in. I just got to make sure that the chassis is properly grounded. So and I'm gonna put the black here because this leads over to here and that leads to the power indicator. So if there's black, we'll have a power indicator. Okay, so then the only last thing to do is kind of keep that wire from coming out, and I guess it's a little tough, but I think I can put a tie wrap around it. All right, so there we've got our plug all in, and I think that'll be much better. Let's just try it, see if it goes on. Yeah, it's on. So I think we're good. So I don't know the best way to kind of lubricate these, but I'm just taking a little bit of grease on a toothpick and seeing if I can get it in on the sides of the switch and move it in and out. Well, that's it for Rob's Fix-It Shop, Old Technology Edition. And, you know, I had fun kind of looking at this old piece of technology and figuring out how it worked and, you know, fixing it up a little bit so I have a nice tool around the shop for when I'm working on antique electronics. I'm old enough to remember my dad opening up the back of the TV, grabbing a bunch of tubes and taking them down to the Radio Shack and testing them all and getting the TV back up and running. And so it's kind of interesting all these years later to kind of take a look at one of those testers and figure out how it worked. And so if you liked the video, please hit like and subscribe, and thanks for watching.